she has running, and she's running 2 times 3.14 kilometers. And the height in kilometers of the hills above the sea level relative to her home. That means her home, okay, is the center. Okay, her home is the center. And it can be modeled with this function, where d is the distance traveled in kilometers. At what intervals in each stretch of rolling hills is the height above sea level? Okay, so the key thing here is the squared. Okay, so this is what a cosine graph looks like, right? The base cosine graph. But if you square it, what happens is this. Okay, we get that, that, and that. So if you square any values that are less than 1, it gets smaller. And all of these values, the negative values, will get squared and it'll turn positive. The negative 1, if you square it, becomes positive 1 again. Okay, you can see the period is just, right, for cosine of z, it's just simply going to be pi. Now what we're doing is, to this graph, right, we're timesing it by 4. Okay, so instead of the maximum being 1, now it's going to be at 4. Okay, at 4. And then we're shifting it down once. So maybe that was a little bit confusing. Here, 1, 2, 3, 4. So it's going to look something like this. Okay, and we're shifting this graph by 1, down once. Okay, so okay, that's the picture of it, right? I just wanted to give you a sense of what the hill looks like. But to actually solve when is h at d is equal to 0, right? Or I should say, we're trying to find out when is it above sea level, so greater than or equal to 0. But finding where it's equal to 0 is key here. Let's replace that with 4 cosine squared d minus 1 is greater than or equal to 0. This is 2 squared cosine squared d minus 1 squared, so it's factorable to 2 cosine d minus 1, 2 cosine d plus 1. Okay, so we're trying to find out when these two values are positive. Okay, both positive or both negative. Now, for this, okay, 2 cosine of d minus 1, if you set that equal to 0, you get cosine of d is equal to half. And similarly for this, we're going to get cosine of d is equal to negative half. Okay, so the answers when it's equal to half is pi over 3, and right, 2 pi minus pi over 3, that's 5 pi over 3. For that, from the center pi, it's going to be pi minus pi over 3 and pi plus pi over 3. Okay, so this is going to be 2 pi over 3 plus 4 pi over 3. Okay, let me create a table here. X, okay, the smallest one is pi over 3. And then it's 2 pi over 3. And then it's 4 pi over 3. And then it's 5 pi over 3. And then, of course, we end at 2 pi. Okay. First, 2 cosine of d minus 1. From the picture, right, we can see that this here is going to be above, okay, bigger than half right here and right here. So positive here and positive here. Okay. Well, right there it's equal to, yeah, it's positive. It's equal to 1, right? And everything in between is negative. See that? It's equal to 0 here, and 0 here is negative. So when is it, for this one, when is it greater than negative half? Well, 2 cosine of d plus 1. You can see, here it is. From here to here, it's going to be greater than negative half. So it's positive up to 2 pi over 3. 0 here. 4 pi over 3, 0 here, positive. And this is negative. So why am I creating this table? Because I want to know when you multiply these two factors, do we get equal to 0 and positive? So you get positive here, negative, okay, it's zeros, wherever there's a 0. Okay, here is positive, negative, and positive, right? We want positive or equal to 0. So this is our answer, that's our answer, and this is our answer. So what's the conclusion? When x is, this is greater than or equal to 0, okay, but less than or equal to 2 pi over 3. Less than or equal to pi over 3, sorry, pi over 3. The whole expression, h of d is going to be positive. Okay, and when x is between 2 pi over 3, 2 pi over 3, and 4 pi over 3, it's also positive or equal to 0. Okay, it's above sea level. And lastly, when x is between 5 pi over 3 and 2 pi, it's also above sea level. So above sea level that actually means we should not include where it's actually at exactly at sea level. Okay, so get rid of the equal sign. That's our solution.